Hello and welcome back. In this video we'll be looking at higher order derivatives, and all higher order derivatives mean is rather than taking a derivative of something, we might take a derivative of something twice or 3 times or 4 times. So yeah, that's all there really is to this lesson. We're just going to be looking at, taking more and more derivatives. This is also just practice in taking derivatives, but we'll just have to do it multiple times. So when we think of a function f of x, we can take its derivative and we write d by dx of f of x. We can also write this as f prime of x, the prime meaning we've taken a derivative. To say that we'll take the second derivative, there's a couple of ways to denote this. We can write d squared by dx squared, and that means that we're taking 2 derivatives here. So one way to think about this is I'm going to be taking the derivative of f of x. Using the prime notation, we can just write f double prime of x. And then we can even go further. We could take, say, 3 derivatives. Oops. And rather than writing 3 primes, 4 primes, 5 primes, and then like having something that looks like this, and we have to sit there and count all of them, what we normally do is you can write how many primes there would be in parentheses up top. So that means 3 derivatives. So for instance, we could have f6. So this would be the 6th derivative of f. And all there really is to any of this is just taking the derivative multiple times. So let's do that here. Let's say that I want to take, this would be the second derivative, d squared by dx squared, of this guy. So the first step, okay, we have this guy. It's written down with say no derivatives. So that's the initial function. Let's say that we want to take a derivative of this guy though. So let's take the derivative of all of this. So here, again, we have a bunch of things being subtracted or added to each other, so we can just take the derivative of each one of these guys individually. So the derivative of 3x to the 4th is going to be 3 times the derivative of x to the 4th, which by the power rule will bring down the exponent and raise it to the 1 fewer power, 1 less power. The next guy, we're going to subtract 1/2 times the derivative of x to the 3rd, which will be 3x squared. We will add 5 times the derivative of x squared, and I've run out of room. I'll continue on the next line. So we're going to subtract 7 times the derivative of x, which is just 1, plus the derivative of 9, which is 0. And that's just 0, so that'll just go away. And then we can simplify the rest. So 3 times 4 is 12x cubed, will be minus 3/2 x squared, plus 5 times 2 is 10x, minus 7. Okay, so here we have the first derivative. And the last thing to do will be to take the second derivative. So let's take another derivative of this guy. The derivative of the derivative. So again, when we take the derivative, we have a bunch of things being added or subtracted from one another, so we'll just take derivative of each one individually. The derivative of the first guy, we have the 12 there, and we'll take it times the derivative of x cubed, which is going to be 3x squared, minus 3/2 times the derivative of x squared, which is 2x, plus 10 times the derivative of x, which is 1, minus the derivative of 7, which is just going to be 0. And again, we can simplify this, so this will be 36x squared minus 3x plus 10. And that's our second derivative. And that's all there is. So here is our second derivative of our initial polynomial. Let's just do more and more examples. Here I want to find f double prime. So the second derivative of f of x, where f of x is equal to 2 times 3x squared plus 1 all to the 6th power. So let's find the first derivative of this guy. So 3x squared plus 1 raised to the 6th power. So here, this is going to be something where I'm going to have to use the chain rule, because I've got all of this to the 6th power. So we have sort of our outside function, and then we have our function that's on the inside. So again, with the chain rule, well, first of all, I have a constant out here, so that constant just hangs around. It doesn't go anywhere. And now I'm going to take the derivative of what's left. So I take the derivative of the outside, and the derivative of something to the 6th power is that something raised to the 5th power with the 6th out front. And then I have to take it times the derivative of what's on the inside. So the derivative of 3x squared plus 1. So the derivative of 3x squared plus 1 is going to be 3 times 2x. The derivative of 2x, or sorry, x squared being 2x, plus 0. So that guy goes away. And if I simplify this a little bit, I've got a factor of 2, a factor of 6, a factor of 3, and a factor of 2. So when we combine all these guys, that'll be 12, 36, 72. Yes. I also have a factor of x, and we have the rest of it. Cool. So this is our first derivative. And now we need to take the second derivative. So we'll just take another derivative of this guy. So 72x times 3x squared plus 1 all raised to the 5th power. So here we have two things. We have two functions being multiplied together. So we're going to have to use the product rule. So we'll take when we use this product rule, I'm going to take the first guy times the derivative of the second, and I'm just going to write it down as the derivative for now. Plus the second guy times the derivative of the first. This will be easy to take the derivative of. This guy will be a little bit harder. So I'm going to focus on this first one for now. Let's continue this over here. So I have the 72x, and I haven't touched that yet. But here I'll take the derivative of this guy right now. And again, I have an outside function and an inside function. I've got some function raised to the 5th power. So I'll bring that power down, raise what's inside to the 1 fewer power. So again, something to the 5th power, if you take the derivative, you get 5 times it raised to the 4th power. But with the chain rule, I'll have to take it times the derivative of the inside. And the derivative of the inside, we already calculated that before. The derivative of 3x squared plus 1, well, that was just 3 times 2x, so 6x. So that guy wasn't too bad to take the derivative of. And then over here, I've got 3x squared plus 1 all raised to the 5th power times the derivative of 72x. Well, that derivative is just 72 because the derivative of x is just 1, and we have that constant left over. So let's simplify this a little bit. Now I've got 72 times 5. That's not too easy to take in my head, so 36. And we'll take that times 6. 6 times 6, 36. So 2,116. And I have 2 copies of x there, so it'll be x squared times 3x squared plus 1 all raised to the 4th power. And then over here I have 72 times 3x squared plus 1 to the 5th power. So it does get a little bit messy, but overall we're just taking multiple derivatives, and that's about it. I think I'll stop there and continue with more examples in the next video.